KTE HB520N, the Photovoltaic Wind Power Hybrid Experiment Equipment, is a training device for the power generation practice by constructing a standalone inverter and a grid-connected inverter system with the electric power generated from solar and wind power. In addition, the measurement of output voltage and current and the efficiency measurement of power generating part are possible according to the load resistance change. The Photovoltaic Wind Power Hybrid Experiment Equipment consists of a total of 4 components: Photovoltaic Wind Power Generation Section, Photovoltaic Wind Power Generation Control Section, Monitoring Control Board Section, and Power Conversion Section, through whose components you could understand the power generation principle of the photovoltaic wind power generation system and drive it directly. Firstly, the photovoltaic wind power generation section was made to generate up to 80 watts of power by installing 4 sheets of 20-watt photovoltaic modules and was composed of 4 300-watt halogen lamps to enable photovoltaic power generation performance tests to be performed using the artificial lighting in the room. In addition, it is possible to test the performance of 60-watt class wind turbine generator through the precise wind speed control by using a virtual wind speed generator. The control section of photovoltaic wind power generation is composed of main power, photovoltaic control, wind power control, anemometer, voltage current measurement, and load test unit as a control panel to control the operation of photovoltaic wind power generators and experiment it. The main power section is the unit of the operational control of photovoltaic wind power generation, and when the power is applied, AC lamp is turned on and power is supplied to each controller. The photovoltaic control section consists of a virtual artificial light on-off push-button switch for the experiment of the photovoltaic module and a banana jack terminal which could be used to measure the DC output voltage generated from the photovoltaic module. The wind power control unit can control the operation of a virtual wind generator and a wind power generator through the on-off of toggle switch by composing the output port of the 60-watt class wind power generator on the control panel. In addition, it is a device that measures the wind strength and is composed of an anemometer that can measure the wind speed and temperature at the same time. The voltage current measuring section is configured to enable the efficiency test of photovoltaic module or wind power generator through the measurement of the DC voltage and current values produced from the photovoltaic and wind power generators. And the load test part is composed of 1 volume resistor and 4 100 ohm resistors in order to perform the load test required for the photovoltaic and wind power test. The monitoring control panel unit could check the experimental data such as voltage, current, and power, etc. of AC and DC by composing a standalone inverter system, a grid-connected inverter system, and a hybrid system, making use of the power generated from the photovoltaic wind power generating part by utilizing the banana jack. The power conversion unit consists of the connector band receiving the electricity generated from the photovoltaic module, the role of transforming the unstable voltage of the electricity generated from the photovoltaic generator to the constant voltage, and the overcharging, the charging controller that protects the battery from over-discharge, the storage battery, which stores the generated electricity as a DC voltage, the standalone inverter that receives DC voltage from a storage battery and converts it to AC to supply it to the load, the grid-connected inverter which supplies power to the load by making a connection with a commercial power system and supplies the remaining power to the system, and the automatic changeover switch that plays a role for the receptors to receive a constant power supply at all times by securing the double or triple power when the main power supply is cut off or the voltage drops below the reference value by automatically switching it to the standby power. Another key component of HB520N is the DA100 data collection device software. Utilizing the software, the real-time monitoring is enabled as the DC voltage, DC current, AC voltage, AC current, etc. are made to be connected with PC for each section, such as photovoltaic module, wind power generator, charge controller, battery, grid-connected inverter, standalone inverter, commercial power, etc. The full components of HB520N include the banana jack cable, DA100 data collection device software, user guidebook, and user training program.